Good afternoon to everyone. We're very happy to see everybody here together. Warm welcome for everyone. This is our next summer meeting of CACOA meetings for Latin America and Caribbean. It's a pleasure for CATIE, for Caribbean Climate Hub, for Cacao, Summer Series, and CIRAD to be here together and share experience to strengthen the cacao segment of the region by sharing this knowledge and have a space to connect. This morning, we have a pleasure of having Dr. Bénédicte Rhoné from CIRAD. She is also based at CATIE, and she will talk to us about improving the genetic profile of cacao. My name is Galia Liano. I work on improvements within the cacao team, and also manage a program here at CATIE. To introduce, say a few words about Dr. Rhoné. She is an engineer and agronomist specialized in genetic profile of the plants from France. She has a doctorate degree from 2008 from Agro-Technical University in Paris, and she worked on the conservation of genetic resources in grain. She has worked with genetic improvement for 20 years, and her specialty is improving the genetic profile of cacao in other species. She has worked as a genomic researcher for cacao at CIRAD, which is a French institute for cacao, and she has also worked with CATIE since 2023. Focusing on forestry and also agroforestry and also genetic improvement of cacao. It's a pleasure to have her with us today. And if she is ready, I think Jenny will also say a few words, and if not, we'll be ready to start with the seminar. Viviana will let us know how to interact as far as the questions are concerned, questions and answers, and also about the timing. Thank you very, very much to everyone for being here. And Bénédicte, thank you so much for sharing your knowledge with us today. Thank you, Mariela, for these words today. It's a pleasure to be in the same forum with you and everyone. A few announcements, as we had mentioned before in other webinars, the questions are going to be made through the chat so that we can have them there when the moment is right for the discussion. We have started publishing the presentations from the past and YouTube. You can access those. You can and we'll be publishing this one as well on YouTube, and also on August 30th we're going to have an international symposium with a slight technical issue. So I will be running the slides, so we'll be able to see the chat. So my colleague will be watching the questions in the chat. Please go ahead. Can you hear me? In the chat, somebody is saying that there are issues with audio. I don't know if it's a question, it's an issue for everyone, or sounds like some people can hear us and others, perhaps it's just one person situation. Good morning, everyone. Thank you very much for giving me the opportunity to present the program of genetic improvement of CATIE. I will also be sharing the next steps. This is what I'm going to share with you today is a result of my research, but of course, this is also a result of work of our team, which is the genetic improvement of cacao team at CATIE. So I wanted to recognize everybody in our unit who has worked on this project. I will start with a short presentation about what is genetic improvement in general. Genetic improvement basically aims to strengthen the characteristics of the factors of interest, for example, the resistance to environmental factor and to diseases, to generate a better adaptation of, in this case, domesticated vegetable species through modification genotype, or in other words, the genetic constitution. As we can see on the slide, there's a very simple rendition of what genetic improvement means, where we cross-pollinate to different crops. For example, one is resistant to virus, another one is high yield, and we combine those to have the genes combined in one future variety, which has both resistant to virus and also is very productive. In the context of cacao, we know that the productivity of cacao in Central America and Caribbean is low. The yield is less than 300 kilograms per hectare and per year. And this can result from either a lack of agronomic management, but also there are a lot of challenges due to diseases such as Monia phytophthora, and sometimes there's a need for new varieties and access for better varieties of cacao for the producers. And now the selection objectives are to have productive varieties in the agroforestal systems, because this is the system is most common in Central America. We need them to be resistant to key diseases present in the region, and also quality is an objective. In the context of improving genetic makeup of cacao, the main selection criteria are yield or productivity, which means, for example, the number of seeds borne by a tree, the size of the seeds, the yield in dry weight, the proportion of healthy seeds compared to the seeds that are damaged by disease, which is the rate of resistance, and also the quality, which is the amount of fatty tissue in the seeds, and also the size and the composition of the seeds. I wanted to highlight the key points of the genetic improvement program for cacao of CATIE. The program started in 1986, led by the work of Dr. Phillips. And here's a very simple diagram. First, we carry out the selection of the best genotypes focused on the characteristics of interest, and then we cross them with the under controlled conditions with selected genotypes. Then we receive the hybrids, which allow us to evaluate the resulting species of this mix, and then we select the best ones, and we carry out a clonal evaluation, which is the evaluation of the clones at the experimental station. And then we distribute the selected varieties to the producers, and both parts of the both hybrid and clonal experiments provide interesting materials for development of new phases of the program. I'm going to share with you a little bit more detail about each step, but I wanted to say that this process of genetic improvement will generate at each stage there is a selection taking place, which means there's a reduction of a diversity, which is considered at each stage. We start with the entire collection, the international collection, which has over 1,200 varieties. And the first step is selecting the about 100 progenies among two parents. We select about 5-10 trees to establish clonal assays, clonal studies, and then this results in 1-2 selected clones. So it's a very comprehensive process to select, to develop an interesting variety. And of course, it's important to understand that this is a very long-term process, because every essay or every study requires 5 to 7 years of evaluation. And the evaluation starts 2 years after the plot has been started. So we're talking about 9 years for each stage. So it takes between 16 and 20 years to identify and start distributing a new variety. For the selection of the parent species of interest, we can work through CATIE, which has access to international collection. There are over 1,200 genotypes. It was established in 1944. The particularity of this collection is that it's a public domain collection, since there are only 2 collections like this in the world, one based in Trinidad, the other one based in Trinidad, and the material that is being conserved here at CATIE can be shared to all countries of the region and the world. Again, this is we use a system of quarantine based on our university practices. The collection is located in 2 places. There's a duplication of the collection. We want to make sure that we do not lose access to the seeds. And there's a regular introduction of new genotypes to keep amplifying the diversity of the collection. It's also important to say that we represent all the variety of cacao with all of its genetic groups, which are shown on this map. And there's also material from other continents, for example, from Asia and Africa. These are materials from the genotype improvement programs from other countries. And so the phenotypic characterization of this material is performed on a regular basis as well. We have here an evaluation of the resistance to diseases with approximately 800 genotypes evaluated through artificial inoculation, just for control for mania and Phytophthora. These are the diseases that are present in Costa Rica. We also carry out the evaluation of the auto self-compatibility. There are over 332 genotypes evaluated with controlled mixes or crosses. It's a way to control the flower. So if the mixing is in controlled conditions, we have a quality evaluation with over 132 genotypes with a sensorial profile defined, and 14 genotypes with organoleptic and chemical characteristics. I'm sorry, I have to turn off the sound. My computer, can you hear me? Yes, we can hear you. Thank you. We also have a genetic evaluation of over 920 3 accessions that are genotypes with molecular markers, which enables to connect the accessions to the new additions to the genotype groups. The collection is organized in a way to conserve the material and not to evaluate in a very detailed way the genotypes, so we cannot evaluate the yield of some of the new additions. So we do not have the data for all of the for some of the varieties that are more difficult to evaluate. But we do use technical documentation and bibliography from other countries, for example, to evaluate the resistance to certain insects and also productivity. When the parental species have been identified, we can start working through the program. First, we mix the 2 varieties that have been identified. For example, one that is resistant to disease and the other one is more productive. We cross them and then develop the seeds. And the seeds are planted to develop the descendant trees, just like the process as a result of sexual reproduction among controlled mix of parental genotypes, where you combine the genes of the parents, but each tree is going to be different from the other one, just like sisters and brothers would be different from one another in the family. They have the same genetic makeup of their parents, but the combinations are different. So each tree has its unique combination of genes. I mentioned that these are the descendants are then propagated through the seeds, and each tree is different from another one within the family. This is done at the Finca La Lola farm, which is located in Costa Rica, has about 28 hectares of land. And the descendants are evaluated within the system, agroforestal system conditions, to carry out the selection that would be of interest since this is the way in which this particular species is usually grown. There is a monthly evaluation of each tree for at least 5 years. And we count the fruits, the healthy ones. And with this evaluation, we're able to select the best trees among the descendants. When we find a tree that has the characteristics that we wished for example, a tree that is both productive and resistant, we will establish we will proceed to a clonal part of the experiment, which means we will proceed with vegetative reproduction, which is insertion or cut, which means that each tree, in this case, in the clonal assay or clonal experiment, now each tree would have the same genetic profile. So this is propagation through inserts, the cloning with the same genetic profile. And this genotype is repeated in each of the trees. This experiment also carried out within the agroforestal system. We evaluate similarly to what we've done before, at least for 5 years, with monthly evaluation, counting the number of healthy seeds, the symptoms of ammonia and phytophthora, and also the raw weight of the seeds. We can also evaluate other characteristics of interest, such as auto and intercompatibility, quality, the indexes of the seed and the of the fruit and the seed, resistance to diseases with artificial inoculations, all of this in order to have more information to select the promising clones for evaluation. We can evaluate them through clonal studies in different locations prior to proceeding to the distribution stage. Once we have the material selected, we select, we multiply the improved clones through insertation and then distribute to the gardens and greenhouses. And these are the varieties of CATIE that have been planted in the productive to the producing farms. One is in Costa Rica and Talamanca, and another example in Osa on the Pacific side of Costa Rica. Another example of our clones on the farm. In 2007, we have made available 6 improved clones. This is very particular because the 2 clones that have the best yield is the number 6 and number 4. They're not compatible among themselves. They're not so compatible, so they have to be cultivated in fully clonal way. They have very good production between 1,000 and 1,500 kilograms per hectare per year, and have really good qualities in terms of quality. Now they're cultivated in 10 countries of Central America and Latin America. If you wish to have more information about these clones, there's a catalog with all of the characteristics and with lots of details about the 6 clones, so you can buy the catalog. We now have a new material with including the promising clones. I don't know if you can see. I don't know if you can see. I don't know if you can see well what's on the slide. To the left, you see the graphs that present the yield potential of the 6 new varieties, the promising clones that we've developed. And you can see that they have very good potential, over 1,500 kilograms per hectare per year, and also has good resistance to diseases, with a percentage of incidence of subject to diseases less than 15%. It's very good for both. If you see for both diseases, in green you see Monia, and the Phytophthora, the orange one, the columns.
Now, we want to continue with this program of genetic improvement. We have 6 hybrid tests established between 2014 and 2017. We can count with more than 6 hectares of the area for these tests, more than 6,000 hybrids that have been evaluated that come from 121 different families with 37 fathers or parents, different types of parents. For these tests, we have the evaluations that we've been evaluating for more than 4 years. And in the section pertaining to clonal tests, we have 3 tests ongoing with more than 4 years of evaluation. They represent more than 3 hectares and 2,800 trees, for a total of 57 different phenotypes. Now we need to do the analysis and selection process of this material in order to continue with more clonal testing over this material. For the selection process, I'm going to explain a little bit more in detail. As I said before, we register for each tree and per month, we register components, total fruit, fruit with Monilia symptoms, fruit with Phytophthora symptoms, good fruit, and the weight of the grain when it's fresh. And with these details, with these data, we can evaluate secondary traits that are interesting for the genetic movement and improvement, and they are the incidence of Monilia and percentage based on total fruits, and the ones with symptoms, the Phytophthora incidence, some aspects of yield based on the weight of the dry grains, also the yield, the potential yield, which is the one that a tree can have without the problem of the diseases, without being attacked by disease. And this comes from yield and a correction between total fruit and healthy fruit. You can also evaluate the stability of the yield and the incidence or the index of the COGS, which is more of an approximation because we look at the number of healthy fruit and the total weight of the fruit. So it's an approximation of how we calculate this index. And this index is the number of cobs that are needed to have 1 kilogram of dry fermented grains or seeds. I'm going to present a little bit over the selection process based on a clonal test. This test has 14 clones that have been evaluated in this parcel. There are 2 repetitions, 2 blocks. And we have in each block 32 plants of the same clone. We can see this in the experimental map where we see the line, each dot represents a tree, and it has a line of 32 points or dots, which represent the trees in each one of the blocks. This trial or test is evaluated for 10 years. And in the graph, we see the number of fruits per year. That's the central bar. That represents the percentage or the average in the whole trial, and the representation of the variation around the production average. We can see in the 3 or 4 first years, it begins to produce. Year 1 is 2 years after the establishment of the trial or test. And then you can see that year number 5, we begin to have a more stable production throughout the next years. Well, that's it for this one. Can we change? Here, there's a representation of the map with the numbers of fruits. When it's very dark, it means that there's very little production. And when it's very clear or light, it's when we have the highest production in the trial. And the number of fruit, or the accumulation of the fruit within the 10 years of production. We can see that there isn't a very clear effect of the clone in relation to the production, but that's normal because production is it's multifactorial. It has to do with genetics, but also with a lot of other elements that influence this trait. On the contrary, we can see that the incidence, we can see the effect of the genotype. For example, there's a genotype that is clear in all the line, and that is the genotype called CATIE R123. And in both repetitions, we have the trees of this genotype, which are hit by disease a lot. And then it's impacted. When it's black, we have about 0% of the cobs infected by Monilia. So we can see that it has an important effect in this disease over this particular clone. And there's another way of representing this, which is in the graph up to the right. We can see that CATIE, these are the incidences between 100 and 100%, 0 and 100% for each clone evaluated in the 10 years under evaluation. And for example, in CATIE R123, we can see that the incidence is very high every year. On the other hand, in CATIE R6, 8 to the top, there's a very low incidence of Monilia throughout all the years. The same with CATIE R56 and 58, also CATIE 81. We can also see that the CCN 51 has an incidence of Monilia that is intermittent, around the 50% of the Monilia incidence. After this evaluation, we can make a multi-criteria selection of the clones. For example, we have 2 genotypes, which are CATIE R6, which one of the 6 clones led by CATIE in the 2000s. and the CCN51. And here we see the representation of the characteristics in this trial. We can see each line in this graph represents one trait. For example, we can start with number of total fruit, then number of healthy fruit, percentage of the incidence of disease, early yield, when does it start to produce in the first years, late yield, the coefficient of variation in the yield, the index in, and the potential yield. The numbers, we're also looking at the seeds, and we can see the lower and the higher ends of the measuring scales for each one. So we can see that the numbers in average fruit goes from 7 to 18 in total fruit. Both have good fruit production, we can see that, but CCN51 has, since it has a low tolerance to disease, it has a lower percentage of healthy fruit than the R6, than the CATIE R6. CCN51 it produces faster because the early yield is better than the one of CATIE R6, but later on, the late yield of R6 is better in this trial. What we're looking for the coefficient of the yield is that we want it to be low. We don't want a high variation. So we want low numbers in the variation. With the seed index, we're looking for a seed index that's low, less than 20. And in the case of CATIE R6, we're a little bit over 20. So we're around 22. But CCN51 has a good seed index. And for the potential yield, it's better than CCN51 because it produces a lot of fruit, but since it has a lot of diseases, its potential yield, what we mean is that the yield without disease would be better than the CATIE R6, but with disease, it's not. With this evaluation, we will see how other clones behave that we want to evaluate. Can you change the slide, please? We have about 10 minutes left. Oh, okay. Can you change it? Here we see the representation of the other clones. And we can see in blue a clone that produces a lot of fruit, but which is RC123. It has lots of fruit, but since it has a lot of disease, we feel that it's a little bit less interesting in the context of Costa Rica, for example, because we have the problem of disease. We have this map for each clone, and we can look for clones that have the traits of interest depending on what we're looking for. So here we're looking for more productivity and resistance to disease. Next. The idea is to, once we've completed the evaluation of these clones, we can establish, well, we want to establish a new multi-local clonal trial these are the areas where we would like to perform these trials. Land Experimental Station is where we're doing the evaluation now, and we would like to expand the environment where we can evaluate the materials to make sure that the material is interesting for all producers. One of the points that we want to also touch on is defining new selection criteria. More than anything, in order to face threats and challenges for the future, like can be new diseases, like the witch's broom, that is not here yet, but getting closer. And also climate change, in order to look for and find varieties that are more resistant or tolerant to droughts, for example, and higher temperatures. We also want to develop a more participative process in order to define the selection criteria. For example, a thought workshop over the selection criteria with the different actors in the sector, producers, cooperatives, technical institutes, and exporters, private sector. And we also want to establish participative selection methods that bring in the producers more, using maybe parcels from producers and the actual selection of the product. Another perspective is using genomic selection. Since we have all this data of phenotypes, maybe we can take advantage of this material in order to use it as a population for training. We have the phenotype facts, so we must phenotype and use molecular markers to create predictive models. And after that, using a population to make a selection, we can only use a genotype of a particular material of the small plants and use the predictive model to establish the genotype value of the material and select the better ones based on the genotype value so that we can establish then the clonal trial. I want to explain a little bit. The idea of this type of selection is to reduce the time for selection and for the program of the genetic improvement when we've seen that using conventional elements, the trial can last more than 20 years or minimum 20 years. So using this process of genomic selection, we can reduce the time of the program making an evaluation or performing an evaluation, well, actually making the prediction of the genotype value of the hybrids without actually performing the hybrid trial, and then just do the clonal trial. In this way, we can reduce up to 11 years the program of genetic improvement. And the other interesting part of the genomic selection is that we can try to do a preventive one using the predictive model that we may, or we create, or that we will create with the phenotype and genotype types. We can try to select preventively genotypes that are productive and resistant to Monilia using this model and without going through the phenotype part, but just jumping into the genotype part. And after that, we can do trials to validate this. So this is a strategy that we could try, but we have to validate this way of doing this with cross data. So from other countries using the same type of data, the phenotype and genotype data, using the same type of them from other countries. Okay, and this is it. I'm willing to answer your questions. And if you need, I can also answer. Thank you, Benedict. Okay, for now, we have 2 questions. First, I wanted to say I'm sorry, and they have other names, but I want to say hello to Dr. Felipe Genero, Adriana Arciniegas. Thank you for being here. Dr. Peguero was asking about year 9, and he was saying that what happened with the productivity of year 9 and why did it drop? That is a question that we have. And we have to expand the investigation on this year. That corresponds to the pandemic. I thought there was going to be a wider growth of the shade trees that could bring down production. And also, I want to say that these genotypes are in another trials, so we can validate the details there in order to be sure of our selection. We're also going to put them in the multi-local trial in order to evaluate potential in other environments. I'm sorry, I had the microphone off. Thank you very much. Well, for being asked if we have the presentation in English, if we can share it. There's a question that they're asking us about the grafting or the patterns that are used for the clones. Do you have information on that? Yes, we have in CATIE 5 proto-grafts. They're regularly used as IMC 67, ET 400. I don't all of them at hand. STI 90, PA 121, and there's another one. I forget the name, but there are a few genotypes that are used in different countries, in other countries, more than anything to increase the resistance to pathogens from the ground. I think it's also important, I don't know if there's a question that I'm not looking at, but it's very important, I think, that we go into the importance of the handling. We have the basis of the genetic basis, we have good genotypes, take it to the producer, but the handling is also important. Can you touch on that a little bit more? Of course. The idea is to have good varieties, but you do have to have a good management of the crops relating to diseases, for example, which is very important. And also the clipping is important to have a good hygiene within the parcel. On this topic, we also need to be careful with the cutting of the shadow trees and the cocoa trees too, because if there's a wide covering, it can create a favorable environment for disease. So, and also good fertilizing of the soil is very important. So all the practices that are performed in order to have a good and a healthy parcel are very important in order to have the potential, or well, to achieve the potential of the variety. Because without all this process, just with a good variety, we won't get a good production. We need all of this management. Maria, I have a question. I would like to take advantage of the moment and to the fact that the doctor's here. There's a graph here. I find it very interesting looking at the number of fruits throughout 12 years or so, because the first year here is actually the second year of birth. In Puerto Rico, maybe there are very high expectations on how much a variety can provide fruit per year. And there are many expectations here that are about 80 fruit per year per tree. So I wanted to highlight how variable a clone or a variety can produce per year. And that I saw here, if I'm not mistaken, that the medium, it's here, which is under the expectations that maybe in Puerto Rico we have, that a clone will give you 80 fruit per year throughout its productive life. So, doctor, if you could explain a little bit this tendency that you saw and what might be realistic expectations for fruit per year according to what you have seen throughout the years in the CATIE, and what might be more realistic numbers, understanding that there are factors like diseases, droughts, storms that can affect those tendencies. Yes, there are a variety of things that we can say. For example, we can see that in this graph, there are trees that go up to over 100 cobs. So this is according to the production that we have in the field. So even though we've got lines of the same, we have trees in the same line that have high variation within the parcel. That's we're in agroforestry system. So there's a lot of difference in shade, trees, and so on, because it can affect the production of the tree because of its genetics. Also, what is it that I want to say? The trials are being handled, at least in the CATIE side, under a practice of low. We are in agroforestry systems with a fertilization of maybe 2 per year with normal. So all of these things we're close to the production levels of the producers, so we can get more fruit if we use other strategies, for example, taking away the shade and so on, and using more aggressive fertilization. But in our case, we are in the idea of performing the selection in a way that is as close as possible to the producers. So we have to also think that in this way, we can also handle years for more, the trees for more years, because if we use too much food for them and there's a very high production the first years, then the tree will suffer faster and they will last less time in production. Thank you. And what I want to say is that we're getting to 12. So we have our sign interpreters. We want to excuse them because it's the end of their available time. But those of you who want to stay to have a bit more of a discussion, we will be here. Okay. So Mariela, go ahead. There are some comments and some points. Daniel has some questions. So he's asking, why don't we use crispgrass in order to improve cocoa? And they're saying, in order to use this, we need to have the genes. So talking about this disease, so there are many genes in the resistance. So it's not that easy to reduce the resistance in a material. So it's not as simple to use this tool, and it's very expensive to perform this type of methodology. And for now, we don't have the possibility of doing this type of investigation in order to achieve or to find a more interesting variety.
Thank you, Professor. We also have a question of how to handle the diseases if a plant has been infected. Well, it really depends on the type of the disease. For example, if it's pneumonia or phytophthora, these are diseases that impact the seed. So it's important to get rid of all of the affected plants for sanitary reasons to avoid propagation of the disease, the spread of the disease. If it's something that is in the soil and may impact the tree, of course, it depends on the type of the disease. It really very disease specific. It's very important to do sanitary cleaning on time. Because, for example, in case of pneumonia or phytophthora, it's important to stop the propagation of the spores at this stage when the spores are being formed. If I may add, thank you so much. When we're talking about systemic diseases that impact the entire tree, it could be something that affects the soil. It's important to eliminate the infected trees to evict propagation. But when we talk about phytophthora, which may infect some of the other parts of the tree, it usually impacts the cob, the seed. We also have the offer from FIA, which offer the genotypes of the second generation that we can try. Eduardo Crawford is asking what's the process for the producers to have the more resistant and productive varieties, or to participate in the experiments. For these multi-location experiment that we are planning, it's very expensive, of course, and we need the support of a sponsor. Right now, we are speaking with Este, for example. Now we're trying to evaluate with them how to carry out this multi-location experiment. And we will see step by step how to establish this and organize this multi-location experiment. And of course, we're gonna need the support of the producers to evaluate this new material. But for example, at this stage, it's in the process of being structured and organized. Thank you so much. Marga Sawando is putting a question. Why are we not reading all the questions? I am trying to read all of the questions, but if any question has been left out for some reason, please feel free to turn on your microphone and speak out. But as long as I can see, I think we've addressed all of the questions. There are some questions about shade, but I think we discussed that already earlier in the chat. Marcos, I'm sorry if there was some question that was left out. Please let me know. One side is saying that the study and so that we need to be very consistent or constant. We need to continue. We need to continue. The study and test the study of the varieties and the testing should the varieties, developed varieties, be reevaluated again? Well, what we do usually, we evaluate the material and then we change to another material. And also I have said that the objectives of the selection can change over time. So we do evaluate the material with these new objectives of selection. And we need to focus on the climate change also, which would require to reevaluate the material that we normally use for planting. And the question from Marcos is if the yields are estimated or they're actual yields. It's an estimated yield. There are estimates. These are estimates because we only have 32 in case of clonal experiments. We have only 32 trees, so it's an estimate to get to the yield by hectare. There's also a question from Honduras about the article by Arciniegas. He's asking to please share that article by Arciniegas. It's not an article, it's a poster that was presented by Adriana in the last conference about the research, cocoa research. I don't know if you have that, if you could share that. Could you locate it at the conference website? I'm expecting to receive it, and then I will be able to share the presentation that was shared today, as well as the article that you're mentioning, and the link to all of the presentations that have been recorded so that everyone can have access to the materials. Great, thank you very much. I think this is a part of Q&A. Thank you so much for Professor Rhoné for the presentation, to all of you for being present here, for the questions, for enriching this virtual space. We look forward to meeting you in 2 weeks. This will be again on Friday. So we have 3 seminars more. I don't know if Viviana would like to share something else, and on my behalf, thank you so much. Thank you to everyone. We learned a lot from this presentation. I would like to emphasize that Professor Rhoné mentioned that she's open to answer further questions. So if you send me some questions, I'll forward to her. What our objective is to ensure that the public has the best information at the tip of their fingers as they work on their agricultural projects. It's almost the lunchtime here. So thank you very much, and have a good lunch. Bon appetit to everyone. Thank you very much. Thank you.